But the answer will surprise you: 99% of life vanishes.
99% of life vanishes.
But sometimes, microscopic moments defy complete erosion. And this is the genesis of amber, nature's ultimate preservative. But we begin by understanding the source at ancient conifer exudate. This raw material, rich in volatile organic compounds, traps its environment. The capture mechanism is rapid, almost instantaneous entrapment. And now that we understand initial capture, let's explore fossilization. The burial subjects the resin to immense, sustained geological pressure. Heat and pressure begin the polymerization of the soft copal to hard amber. But this long process seals the specimen away from oxygen and moisture. This anaerobic environment is key to exceptional morphological preservation. While we see external features, delicate wing venation, even hair structures. But compare this to soft-bodied fossilization. Amber is far superior in detail. Even the tiny compound eyes retain their original, multifaceted structure. However, morphology is only half the story of preservation. The real prize scientists seek lies at the molecular level: DNA. On DNA, the blueprint of life is notoriously fragile in ancient samples. In amber, the initial entrapment halts degradation rapidly, but does not stop it. Over millions of years, even minimal heat causes hydrolytic damage to the chains. Scientists use ultra-sensitive techniques to isolate what remains of the genetic code. A microscopic drill bit targets areas suspected of containing organic material. What they recover are short, fragmented sequences, not complete genomes. These fragments require massive computational power for analysis and reconstruction. The sheer age of the amber presents a fundamental barrier to full sequencing. And now that we understand DNA fragility, let's compare amber environments. Amber varies drastically based on its source tree and burial conditions. A warmer, faster burial leads to excellent physical preservation, but faster chemistry. Water intrusion, even minimal, accelerates the chemical breakdown within the matrix. In exposure to the surface environment reverses the isolation that aided preservation. But these fissures become highways for destructive external agents like oxidation. Oxygen attacks organic residues, effectively erasing the delicate molecular tags. When oxidation wins, the fossil becomes visually interesting but scientifically inert. Understanding these limits defines what we can truly learn from amber specimens. We can reconstruct ancient ecosystems from cuticle structure alone without DNA. But even gut contents can reveal ancient feeding behaviors with remarkable clarity. The resin chemistry is complex, far removed from modern synthetic polymers. But the natural hydrocarbons involved cross-linked in highly specific, resilient geometries. But this inherent chemical stability is why amber is geologically robust. But robustness does not equal immortality for delicate biological material. The color variation reflects mineral content and exposure duration during fossilization. The surrounding matrix dictates the final chemical environment for the trapped life form. Feathers trapped in amber show pigment preservation, offering color clues. However, melanins degrade slowly through oxidation, fading over deep time. But the majority of high-quality specimens originate from specific ancient geological formations. For the preservation of soft tissue, like a lizard's clear eye, suggests rapid sealing. This amber effect is unique in it's not true permineralization, but encapsulation. But chemists must employ highly specific solvents to safely access internal structures. Conversely, improper handling can rapidly dissolve the preserving matrix itself. Every passing million years adds a layer of chemical noise to the original signal. The oldest amber, over 100 million years, yields the most fragmented data. The constant pursuit is minimizing contamination from modern biological sources. A successful ancient DNA retrieval depends on the original organism's resilience. The differences between 20 million years and 100 million years are vast. Even plant spores, robust as they are, show significant genetic erosion. Amber is a stunning archive of form, but a challenging source for pure sequence. The trapping process is nearly perfect, the subsequent geological journey is not. We look back millions of years, seeing life held perfectly in golden suspension. The transformation from sticky fluid to solid, immutable resin defines its value. Every bubble, every trapped air pocket tells a story of that moment. But amber remains the clearest window we possess into deep, lost biological history.